So, hi everyone, I'm Francesco Santini. I'm Associate Professor at the Department of Mathematics and Computer Science at the University of Perugia in Italy. And this is the title of my paper and the video I'm going to show to you. So, multidimensional stable matching problems in abstract argumentation. So, let's start with the intro and with the motivations. Pham Minh Dung, in his pioneering work on abstract argumentation, 1995, showed how to encode stable marriage problems, SM for short, into an argumentation framework. So basically show that stable extensions in an abstract argumentation framework correspond to stable marriages in the corresponding problem between, for instance, men and women, so a set of bipartite bipartite sets in the original formulation. So the stable marriage problem has been extended in several ways. The extension I'm going to consider in this presentation, also considered in the paper, are multidimensionality, so n-dimensional stable matching problems with n greater equal than 2 dimensions. So you do not only have bipartite sets, but you can have tripartite sets and so on. The list of preferences of men or women can have ties, so the preference list for a man or a woman is not strictly ordered. And also we can have stable matching with incomplete list, so some preferences are missing. Many of such extensions are NP complete or NP hard, so interesting to study in artificial intelligence. The motivations behind the study are that, for instance, argumentation solvers can be tested on such kind of graphs, so on our abstract argumentation frameworks derived from such problems, to check if solvers work well. And also studying the complexity results of n-dimensional stable matching problem may suggest the complexity of argumentation semantics on different graph topology. So very short slide about abstract argumentation. In abstract argumentation, you basically have a framework which is a graph where you have nodes as arguments and attacks represented by edges. So in this case, A attacks C, in this example. There can be different definition of semantics. The one we are interested in this paper, specifically in this paper, is the stable semantics. So stable semantics defines which sets correspond to stable extensions. So a subset of arguments is stable. Okay, and so the extension is stable if the subset is conflict free, so there is no attack between the arguments that you select. And the elements you select, so the subset of arguments you select attacks all the arguments left outside. In this case, ABD is an example of a stable extension because there is no attack among A, B, and D, and all the elements left outside, so C, in this case, only C, are attacked by ABD, in this case, by both A and B. So a stable marriage in the original formulation in 1972 by Gade and Shapley considers bipartite sets where you have, for instance, men and women. So what you want to do, so you have n men and women, what you want to do is to match each man with a woman and vice versa. Okay, so in the end you want to have n couples. You want to consider all the men and all the women. So you have, in the end, you want to have a perfect matching where each man is considered in a couple and also each woman is considered in a couple. Also, you have preference lists. So in this case, they are represented as matrices. So you have the list men's preferences and women's preferences. So for instance, first matrix, and you can read the first matrix and the second one column after row after row. Sorry. So M1 prefers woman 1 over woman 2 and over woman 3. So these are preferences are ordered. 1 is better than 2, 2 is better than 3. So it is the position in the preference list. Same things you can also have for women preferences. So second matrix, woman 1 prefers man 1 over man 3 and then over man 2. Okay. So how to say if a match is stable? So if there is a blocking pair, the matching is not stable. So what is a blocking pair? So a man MI and a woman J form a blocking pair for this matching. So the matching is not stable. If MI prefers woman J to his current partner in the matching, and woman J prefers MI to her current partner in the matching. So basically, if you know that the preference of man 1 and for woman 1 is better than who is married with in the current matching, and the same also for woman 1, okay? M1 woman 1 in this case is a blocking pair, and this matching here is not stable because of this blocking pair. Okay, if you have a couple where each partner wants to change, okay, it is a blocking pair and the matching is not stable. Okay, Tung found in 1995 found how to translate this kind of problems, so bipartite problems, classical stable marriage problems, into abstract argumentation framework. Here you find the definition, but it's better to show it in an example. So in this case, you have these two lists of preferences, and the one below is the abstract argumentation framework corresponding to the stable marriage defined by these two matrices. Basically, you add an attack if, so for instance, first row, first column, and one prefers woman 1 over woman 2. That's why the argument representing man 1, woman 1 attacks man 1, woman 2. So if the same man prefers one woman over another, you pose an attack from that argument to the other one. Okay, so the best preferred choice rules out the worst preferred choice. The same also for women. So basically, you can add attacks in this way. The stable extension in this case is this two arguments here. Okay, so in this case you have n times n arguments in this kind of abstract frameworks. This is a stable extension, and it is also the only stable matching in the original problem. Okay, so all the stable extensions in this case represent a stable matching. So you can solve a stable matching problem just by translating it into a abstract argumentation framework, and as in this case, and then you find all stable extensions. So what I did basically in the paper, in multidimensional problems, in 1976, Donald Knuth proposed 12 open questions about the stable matching problem, one of which required to generalize it from 2 to 3 parties, so not only 2 dimensions, but 3 dimensions, for instance. He considered to have women, men, and dogs, okay? But Knuth did not specify any precise definition of preference or blocking triples. Before you had blocking pairs, now you have blocking triples. One can conceive a number of ways to define such a problem. So in the literature, you can find many different ways to do this. In this paper, we consider 3 different ways to consider preferences and blocking triples. So the three-gender stable matching problem, 3GSM, the three-person stable assignment problem, 3PSA, and the three-dimensional stable matching problem with cyclic preferences, C3DSM. So just to give you an example, the 3GSM basically extends straightforwardly the two-dimensional problem to dimension 3. So you have three sets which are tripartite, so there is no intersection. A match in this kind of problem is a complete match of the three sets, so a subset of X times Y times Z, such that you cover all the elements of X, Y, and Z which appears only once. A matching is unstable if there is a triple, so in this case a blocking triple, where each component of T prefers the pair of remaining components to the pair it is matched with in T, in the matching. So it is a straightforward extension of the two-dimension problem. So this is an example. So in this case, you have a couple. So M1 has a preference for woman 1D1, woman 1D2, and so on. And what you can see below is the corresponding abstract argumentation framework. These are the stable extensions, who are also the stable matchings in the related problem. So what we provide in the paper is an extension of what Dung did, so an encoding of the 3GSM as an argumentation framework. So we just show how to translate a 3GSM problem into an argumentation framework. We also have the proof that a subset of arguments, a subset of the arguments that you have in such a derived framework represents a stable, if it is a stable extension, it is also a stable matching problem, a solution to the stable matching problem, so stable matching. So all the stable extensions correspond to stable matching in the original problem. And we show how to extend this to n greater than 3. So you can have n GSM. So you can also raise the dimensionality. You can have 4 GSM problems and so on, 4, 5, 6, and so on. This is what we do in the paper. We do the same also for the other two ways of dealing with preferences and blocking triples. I'll not detail them here for the sake of brevity. Okay, the different problem. We do the same also for these different ways to consider preferences. We also consider incomplete lists and ties in preferences. A preference list is incomplete if some preferences is missing, and it has ties, so SMI and SMT with ties if you can express the same preference for more than one possible partner. What we do in the paper is that we define this 3GSM IT problem. So having ties and complete list is classical in stable matching problems. We have this incomplete list and ties also for the 3GSM, only for the 3GSM problems. We show the encoding, so how to encode this problem, the 3GSM IT, into an abstract argumentation framework. In this case, you still have that all the stable extensions correspond to stable matching, but you have to discard those stable extensions that do not completely cover perfectly the sets that you have. Okay, it might happen that you also have some stable extensions that do not cover all the elements in the three sets. This is an example of the problem, okay? Where you have the dash, it means that the preference is incomplete, and it may happen, for instance, that you have the same preference for more than one couple. So woman 1 has two couples with the same preference, 3, okay? So, in conclusion, what we did, we have shown that how different multidimensional extension of the stable matching problem can be modeled by abstract argumentation frameworks. Stable extension exactly cover the set of solutions in the corresponding matching problem. The two-sex encoding was originally proposed by Doom in his pioneering work, so we extend, the philosophy was to extend that work with multidimensional problem and also incomplete preferences and preferences with ties. Real-world application are, for instance, the assignment of graduating medical students to their first hospital appointments, even if I think that this procedure changed a bit in the last times. As future work, we would like to study the complexity of these problems because they can help in understanding the complexity of solving the stable semantics and part-type frameworks. And also, we would like to generate a synthetic benchmark of abstract argumentation framework obtained from random and dimensional matching problems, just to test solvers working on this kind of extensions. Okay, so thanks for your attention. Time is over. These are my contacts. I will be very happy to answer to your questions at SAM 2020. Thank you again. Bye.